multiplication law of probability. Okay, just you have learned that probability of the event A by B, that is conditional probability of the event A when B has already occurred, is P A intersection B by PB. Okay, don't you see that there is a possibility of getting multiplication rule here? Doesn't it imply that joint occurrence of two events will be PB PA by B? Or somebody want to write this way also, this is also true. PA multiplied by PB by A. This is also true. Okay. Joint occurrence of two events A and B is probability of the event B multiplied by probability of the event A when B has already occurred, and this one probability of the event B when A has already occurred. So this is the case where we multiply two probabilities. We have never done in class 11 course, it was not there. Multiplication rule was not there, but now we understand what is multiplication rule. And let us clarify this multiplication rule with one example. Suppose in this container there are 3 white and 7 red balls are there. Okay. 2 balls are drawn one by one without replacement. What is the probability that the first one is a white, second one is a red? Understand? I am taking 2 balls from there one by one without replacement. What do you mean? That we have taken from there, we'll keep in our pocket and then we make the next row. So if we take the white ball and then the red ball, then this is joint occurrence of two events P W intersection R. Some of you write this manner, it is multiplication, no? P W dot R. Both are same thing. Now, which one you are doing first? First one is a white, second one is a red. So I will be getting probability of red when probability of, you are taking the first one is a white, second one is a red. So you write PW, first one you are taking white, then you are taking red when white is withdrawn. So PW going to be, PW is what? All of you can see that it is 3 by 10. This multiplied by 7 by 9. Okay. So this is 21 by 90. You understand the meaning of this? And this case we can use, we can extend it for 3 events also. For 3 events A, B and C, for 3 events A, B, C, if you want to find P A intersection B intersection C, this will be P A, P B by A, P C by, we can extend the case. Like for this problem, we are drawing 3 balls. What is the probability of getting without replacement again? What is the probability of getting first one white, second one red, and third one is a white? This we have to find. So this how will you write? This is first one white multiplied by second one red when white is taken, multiplied by third one white. When you have taken first one white, second one red. So first one white, what is the probability? 3 by 10, red 7 by 9, then white 2. How many are left? Because 1 you have taken and kept in your pocket. So out of 10, how many are left over there? 9. So it will be 7 by 9. Then step by step, then 2 balls are withdrawn. So 8 are left. Out of these, 2 white and 6 red balls are there. So it will be white you are taking again 2 divided by 6. No, 2 divided by 8. This is the case. Okay. This way probabilities can be multiplied. We can continue this process for many cases. Okay. So multiplication rule also, we have got the two probabilities can be multiplied. PA intersection B will be PA multiplied by PB by A. Now, what we are going to do, that independent events we'll learn. Independent events. What are those? Two events A and B are independent if occurrence of one is independent of occurrence of the other. Okay? Two or more. It may be for more than two events also. So if A and B are independent, you can write P A intersection B equal to PA into PB. Why have you written this? Why did you get this formula? Suddenly you cannot multiply this way. Now for independent events, A and B, PA by B will be PA only. No way it is dependent on occurrence of A. Similarly, if you want to write PB by A, this will be PB only. Okay. So how to derive this thing? Since just multiplication rule we have learned, PA intersection B equal to PB into PA by B, or at the same time PA into PB by A. Once you are saying PA by B equal to PA or PB by A equal to PB, then PA intersection B will give you PB into PA or PA into PB. So for two independent events, this is the case. Here again, the probabilities are going to be multiplied. Let me explain with one simple example. Like if I can take an example where a coin is tossed and a dice is rolled. No way getting a half is dependent on getting a prime number in a dice. Okay, so they are assumed to be independent events. So suppose you want to find, the problem is that only a coin and a dice is rolled. What is the probability of getting a head and 6? Okay, if you say that I'll do it by counting, I have no problem, you can do, but this will be huge because head has possibility 1, 2, 3, 4, 5, 6. Tail also the same manner, it can give you 1, 2, 3, 4, 5 or 6. So how many points will be there in the sample space? 12 points. Getting a head, if you write the sample space here, this is head 1, head 2, this way head 6, tail 1, tail 2 and tail 6. Okay, so 12 cases, head 6 is just one event. So one will say that it is 1 by 12. But now somebody want to check whether they are really independent or not, because here you found by counting. Probability of 8 will be what? 1 by 2. Probability of getting a 6 will be what? 1, 2, 3, 4, 5, 6. 1 by 6. You multiply these two. pH into P6. Half into 1 by 6. The result is 1 by 12. Okay. So probability of joint occurrence of two events, again we are finding here, but here two events are independent events. Then no P A by B or P B by A. You will simply write P A intersection B, or some one can write this manner, P A into B also useful. You can write this also. This also you can write. There is no problem. A intersection B, in place of A intersection B, you can write P A into B. Okay. Now, for two events A and B, if they are independent, I am going to discuss one very important theorem which you can expect in a board exam. Theorem for two independent events A and B, A complement and B are also independent. A and B complement are also independent. A complement and B complement are also independent. Okay. This proof may come in your exam. So be careful. Proof you must learn properly. This I'll give you the proof of number 1. Rest 2 you will try at home. Proof. Since A and B are independent, therefore PA intersection B equal to PA into PB. Isn't it? Now we have to prove these two independent. So required to prove what? PA complement into B equal to PA complement into PB. This we want to prove. How to prove it? Here, left hand side, if you take PA complement B, this I have told you earlier, that's why if you consider A complement intersection B, then it is this part. All of you will agree with me. This is nothing but B minus A. So if somebody write this is P B minus A, and then he or she is telling it is PB minus PA intersection B, then it's okay. It will be PB minus, as A and B are independent, what do you get? PA into PB, obvious. So you take PB as common. 1 minus PA this is PA complement into PB. So what will be your conclusion now? You got, therefore, PA complement intersection B is equal to, it is something like this. PA intersection B equal to PA into PB. Then you can say that two events are independent. Here also you are getting the same thing. PA complement into B or intersection is equal to PA complement into PB. Similarly, you can prove that P A into B complement equal to PA into similar proof. You must try. And for third one, I am giving you the clue, but you must try yourself. By using De Morgan's law, you will write this one as 1 minus, then you will try to prove it, and you must show your calculation tomorrow. Okay, this proof is expected in exam. I tell you the proof. This you write now. PA plus PB. Okay, so it is 1 minus PA, and these two are independent events. We can write. So you factorize this. This is going to be PA complement into PB complement. Alright. So this is the thing. Okay.